So today we're going to be looking at the Anthony's Creek Watershed. So the Anthony's Creek Watershed has a 146 square mile drainage area and is located within Greenbrier County, West Virginia. It is also a sub-watershed of the Greenbrier River watershed, and you guys might have heard of Anthony's Creek because you might have been to Blue Bend Recreational Area, Lake Sherwood, or even Sioux. Majority of the watershed is located within the Mon National Forest, and the area is used mostly for recreational activities, and these might include camping, hiking, trout fishing, anything else you could think of. So within this area, we want to look at the agricultural land and septic systems that are installed along the stream because these are considered the impacts. So like I said previously, the Anthony's Creek watershed is used recreationally mostly, but you also have some more designated uses which include public water supply and maintenance of aquatic life. And what I mean by the maintenance of aquatic life is that the watershed is used as a warm water fisheries and for also trout stocking seasonally. And below I have the water criteria table that was provided in the TMDL paper, and it highlights the pollutant of fecal coliform bacteria and it describes the allowable amount in the table on the right. So Anthony's Creek is a 303 delisted stream, and this is because when the West Virginia DEP did the TMDL on the Greenbrier River, they divided the entire watershed into sub-watersheds based on the 303 delisted streams. So I found that Anthony's Creek is a listed stream within that document that summarizes the Greenbrier River Watershed TMDL. And it's listed due to bacteria and sediment, and these two pollutants are a threat to the quality of the stream. And although Anthony's Creek is within the Mon Forest for majority of its length, we also have some human impact along it. So in the picture on the left, it displays some human development of a road, and you also have a bridge with riprap material which channelizes the stream and changes its natural flowing conditions. So here I've provided two photos of Anthony's Creek at two different locations, and I just kind of wanted to depict what Anthony's Creek looks like. And through the presentation I have different photos, but at every location it looks different. So here are just two more, and on the left you can see the bank right here, and that is an example of erosion, and something might have been going on upstream to cause flow to increase and cause erosion to be more susceptible right there on that bank, but that erosion right there is going to be a source of sediment entering the stream. We also have a lowland bridge right here on the right, and since it's so low to the stream bottom, we can pretty much expect sediment and other debris to get stuck behind that bridge, which is going to prevent water from flowing through the bridge and also prevent aquatic life from swimming up and down the stream. So, like I said, Anthony's Creek is a sub-watershed of the Greenbrier River, and when the West Virginia DEP did the TMDL for the Greenbrier River watershed, they divided the others up into sub-watersheds, and so I could not find any information pertaining to the Anthony's Creek TMDL directly, so I'm going to use the Greenbrier River watershed because it's practically the same, and also it's going to give us more information. So the Greenbrier River is located in eastern West Virginia, and we have a lot of major tributaries, and those include Anthony's Creek, and you might have heard of Knapp Creek, and probably East Fork and West Fork of the Greenbrier River. So within this watershed you have a lot of land use. You have forests, you have grasslands, you have pasture, and you also have a lot of karst geography. And karst geography is going to cause there to be a very rapid recharge of groundwater, which is going to put our groundwater at risk. And so when there's a rapid recharge rate, that's going to cause the water that's being infiltrated, it's going to cause the pollutants that are stuck in that to have less time to be cycled out or to be removed by natural processes. So the groundwater is going to be at risk for more pollutants, and we don't want that. So I provided a table that lists the major contaminants and its sources. So the only major contaminant that the West Virginia DEP is concerned about within the Greenbrier River watershed is fecal coliform. And so we have point sources and our non-point sources. So our non-point sources are going to be sewage and treatment plants, our combined system overflows, and then our non-point sources, which are failing on-site systems, direct discharges of untreated sewage, and runoff from agriculture and residential areas. So you see our point sources are going to be the ones that are permitted under the NPDES permits. So the West Virginia DEP did a lot of studies to develop a TMDL, and so they started off with doing mining data analysis, which is used to find the sources of pollutants, and it represents loads from both point and non-point sources. And it also simulates in-stream processes, so they get the whole picture of what's going on within the watershed. They also took water quality measurements, and they sampled a lot of parameters. So you could have had pH, conductance, temperature, DO, and they also did this at different stream conditions, because when there's a big rainfall event, you're going to have different results than you would if it was a dry time of the year. And so they took these samples at all different times of the seasons and to where they get different flowing conditions. Also, they determined the TMDL source allocations, and these include waste load allocations and load allocations. And the waste load allocations are given to the NPDES permitted discharge points, and load allocations are given to the discharge points that are not permitted. And so this all resulted in the DEP allowing fecal coliform NPDES permits to remain at the amounts that I listed on the right. Also, load allocations were assigned to non-point sources, and so these include non-point sources that were not allocated beforehand. So they assigned load allocations to straight pipes, to even pastures, forested land, and grasslands. And the West Virginia DEP stressed in this document that even though they assign these things as load allocations, they want to state that, like the straight pipes and some other sewage or septic systems that are not permitted, they're not saying that those shouldn't be permitted, they're just saying that for right now they assign them as load allocations. Then we have them stating that fecal coliform reductions will require elimination of the CSSOs, illicit discharges, straight pipes, and leaking septic systems, and these reductions will have to be done through time as a process, one day at a time, because this is going to take a lot of funding and a lot of more science, and it's just something to kind of include in the information, because this is what they're deciding that they should do to help this, to rid of this pollutant. So the West Virginia DEP plans on monitoring a lot of things, and one of those things is public sewer projects. So first they've got to make and develop public sewer projects, and then they're going to monitor afterwards. But these projects are going to need a lot of funding. Also, they plan on doing a lot more compliance visits to these NPDES permitting sites, and you're also going to have a lot more non-point monitoring, where they're going to go out and find these straight pipes and go to agricultural land and see what the pollutants look like in these areas. And also you're going to have TMDL effectiveness monitoring, which is going to come after the TMDL is completed, and they're going to make sure what they came up with and what they're doing is actually helping. So after the TMDL of the Greenbrier River, I'm going to shift back to the Anthony's Creek watershed and look at the health of it according to its biotic factors. So we're first going to look at the average West Virginia Stream Condition Index score, and that score for the Anthony's Creek watershed is 77.092, which is relatively high. And if we look at what the West Virginia DEP describes this score, they describe it as below average compared to the reference sites. but a score of 78 to 100 is highly comparable to reference sites. So a score of 77 is really good. The only thing that concerns me is that majority of this watershed is within the Mon National Forest, so I feel like it should have a higher score, but at the same time we do forget about the human impact within the watershed and what we're studying while we're looking at this watershed, and there's going to be some things that affect this score, and so that kind of makes sense. But also looking at the upstream and downstream conditions. Upstream, of course, at the headwaters, we're going to have a lot of tree coverage, a lot of large substrate, a lot of riffles to support biotic life. You're going to have a lot more bugs in this area than you're going to have downstream. So at the headwaters, it looks really good for biotic life. But as you shift downstream, like to the picture on the far right corner on the bottom, you're going to have downstream of Anthony Creek, and you can see there's still tree coverage, and it's a wider part of the river, so you're not going to have as much tree coverage over this stream, but it is a lot different than what you see on the picture above it. So you're going to have a lot more sediment. You can see not as large substrate, which makes sense as you go down the order of streams, but still you have a lot more sediment, which bugs aren't going to love, but you still do have some larger substrate here and there, and the trees along the edge are kind of good. I mean, they're there. There's not a whole lot of erosion, so kind of less sediment in that sense. So after talking about aquatic life here and how they're going to thrive versus in the upstream versus the one in the downstream, we're going to look at the abiotic factors of the stream. So first we want to look at the pollutants that we've noticed throughout the study is fecal coliform and sediment, and so they're going to definitely be present. But in this area right here, it looks like it's probably in the Mon because there's no development whatsoever. You have large substrate again. You have trees along the edge, so there's going to be less erosion. But there's always those areas that don't have this where humans have started to develop. And like in the pictures previously posted in the presentation, you can see that where that road's going in, there's riprap that's going to channelize the stream, and you're going to get pretty fast flowing water there where it's channelized and versus here. And so you can pretty much summarize that like some areas are good and some areas are bad, and that's probably why we get an average score of that. The biotic score of 77 is a little below reference because there are some things that kind of tweak it, but you also don't have as much erosion here. Dissolved oxygen is going to be higher because you have a lot of riffles, and you don't have as much sunlight reaching the stream, so the stream is going to have lower temperature, and conductance is going to be lower, probably because there's not as much development and earth disruption. So in the NPDES permits, within the Anthony's Creek watershed, we have 3, and these 3 are general permits, and one of them is the wastewater treatment plant at the Blue Bend Campground, Lake Sherwood Recreational Area General Sewage Permit, and then we also have the Anthony's Creek Correctional Center General Sewage. And when I looked at all this information, I couldn't find that there was any violations. So I separated these permits into 2 different permit types. So we got the general wastewater treatment and then the general sewage. And the contaminants for the general wastewater treatment is nitrogen, phosphorus, and chlorine. And these sources are going to be due to the treated water being released into the stream. And let's say the equipment wasn't working right, or the process isn't working. So you're going to have these contaminants entering the stream. And so nitrogen and phosphorus, that could cause a lot of issues. If you have excess amount of these things, you're going to have algae increase also. So we want to make sure our equipment's working and the process is working. So for our monitoring regimen, we're going to make sure we're going to inspect our equipment and we're going to regularly collect grab samples, probably monthly. And if we notice that our grab samples are saying that these contaminants are present, we need to inspect our equipment further and make sure they're working so we don't contaminate the stream. Our general sewage permits, we're going to probably have fecal coliform being the pollutant. And the sources of this is just gray water, raw sewage, and sewage line leakage. And once again, we want to inspect the equipment and making sure it's working properly. And then we can also take grab samples. And we can always increase the ability of the equipment to do a better job by increasing funding for these things. And that's part of the whole process of this TMDL. Is the West Virginia DEP wants to stress the importance of equipment that works properly, so we're trying to get funding for that. So overall, these are my cited sources that I used for the presentation, and I hope you learned something, and thanks for listening.